Hi, I'm Jason Ward. I'm an assistant professor at NC State in the Biological and Agricultural Engineering Department. I work primarily with precision agriculture and digital agriculture technologies and how they intersect with making good on-farm decisions. So today you're probably wondering why we're standing in front of a cotton gin in a cotton field when you're really here to learn about soybeans. Well, I think that I can make a good case for some work that we've been doing in cotton to create traceability and value up and down the value chain that can translate very easily into the soybean market. Once we identify the technology gaps and the implementation, we might be able to create some really interesting opportunities to decommodify your crops and to create some additional value. Primarily, if we look at the cotton market, there's been a lot of work around, let's say, a garment manufacturer wanting to be able to say that a crop was made with a particular set of in-field practices, whether that's related to protectants, if that's related to things like environmental soil measures, a lot of things that we can do to create better sustainability. And they've gone so far, Cotton Incorporated and a lot of industry partners have worked together to kind of create a framework that defines that word sustainability. And so now, with traceability, we can actually start to tell that narrative with real data in a way that's driven, that's auditable, people can actually confirm. And also, we're able to tell stories of farmers a little bit better. If somebody picks up a shirt and says, oh, this was made in North Carolina, right? This is North Carolina cotton, or Georgia, or South Carolina, Texas. So it's a lot of interest around this idea of creating traceability. And I think that we can create value for both the producer and through the value chain to the end user by leveraging some of these traceability technologies we've been able to proof out in the cotton market. The key technology that has allowed the cotton system to work is the discretization, the unitization of the load, right? So whenever that cotton module is made, it gets assigned a serial number. And that serial number can be read both visually with a barcode scanner, or most importantly, remotely with an RFID tag, right? Radio frequency identification. And that means that we can use remote readers to identify this individual module. So on its own, that module number has little value. But the modern cotton production system, that picker, when it's making that round module in the field, it logs when and where that module was made. Okay? So that's kind of the first step, because that ties the module to the field. That creates that first data connection. So now, if we want to go to the field level, we need to create a spatial basis for that information. Where did that module come from? So what we need to do then is we take the yield data, and most yield data comes in at a 1 second rate. So now we have a very fine spatial data set, and using the timestamp of when that module was made in the field, we then assign that module number to every yield point that went into making that module. So now what we have then is the idea of these 6 rows, by however long it is where this module came from. Typically that's somewhere between 2 and 3 acres, depending on yield variability. So that's the first kind of ground truthing. What's interesting is once we have that in place, then we can start going forward through the value chain. So then what we have is we have this unitized, uniquely identified round module. When it arrives at the cotton gin, those bales can be read, with the RFID tags right when they come in. So they can be associated with a load number. So now we've got field location, bale or module identifier, load identifier. So now we start kind of building this chain. And then that clean fiber gets baled. And that bale is what's sampled for quality measures. Okay, so in cotton, that can be things like mic, which is fiber diameter, length uniformity, color. Right, so there's a lot of different factors that go in there. So then once we have that quality measure, assigned to an individual bale number, and we know which module number these bales came from, and then we know which load number it came in on, and then we know which field it came from, and from the yield data, then we know where in the field it came from. So essentially now we've created the full data pipeline. So we can now trace that unitized piece of agricultural product, but now it actually has a value, it has a name and a place and a job, right? It's not just mixed into the system. So we can track it from this field all the way to this finished bale, and that bale is where then the yarn gets spun, that makes clothing, makes the things we use every day. So in the current system, most of the costs actually occur in equipping the machine or activating the necessary options to generate what's called an HID or a harvest ID file that includes the tracking information for that round module on the machine. All the rest of the handling steps and the quality grading are already present in the delivery of the product to the gin and then further upstream. So really there were no additional testing costs. There were no additional handling fees. Granted, that cost does live at the producer at the moment, which is why I thought it was really important to find out what we can do in terms of creating value for their field. How can they optimize, look at varieties, look at inputs using the same information? But really, the cost is really just limited to the options on the machines. And sometime in the future, that may become, just a part of the original package. So I think that's really kind of an interesting idea, that there's all this data was already being generated. All that we did was find a way to collate it and connect it in a way that created outcomes that worked bidirectionally through the value chain. So the current cotton harvesting paradigm has radically shifted in the last few years. Deere is making the new modern cotton picker that has all this technology already integrated into it. So literally in the field, it's a paperless process to execute what we just talked about. One of the most interesting things about the paradigm shift in cotton harvesting is that it has kind of happened during this, kind of downturn in pricing. And in this new harvest system, labor reduction is very important and has definitely been realized with this round module harvest system. So by utilizing this particular harvest system, you're able to reduce your labor costs and find other ways to compete on value, right? Because basically in the cotton, it's a formula. They take your quality factors, they put it into a formula, and then that's the value, right? If there's any additional premiums, it's on top of that down the stream somewhere. So it's essentially, it's a kind of a formulaic system. So I think that there's a lot of people who are interested in moving to the new technology for the labor savings, since it is a tighter market. And you're already making a significant investment in the machine. For just a little bit more, all of a sudden you unlock this entire capability, right? And I think the same thing is going to be true if we look at a commodity crop or how it's currently being handled, with, let's say, a truckload. There's been some interesting work done through Ag Gateway with what's called the CART project, where they were actually kind of figuring out what the data gaps are that would allow this individual truckload, or could even be a wagon load, right? If we're talking about soybeans in the field, how do we track that individual offloading event and identify this commodity as it leaves the farm gate? And so, there's a lot of interesting things that we could do. We could maybe put a Bluetooth, emitter and a receiver, somewhere on the wagon and also on the combine, right? So whenever that cart comes up and it says, "Hey, I'm here. This is the random number that's assigned to me, or the incremental number that's assigned to this load. So whenever you offload, track this number inside the combine, and I'm going to go on and do my job," right? Maybe that same number then has to get transmitted to the truck, right? If it's if a wagon is being used for in-field transit. And then maybe whenever it gets to the elevator, whether that's on farm or to a buyer, then maybe that number gets transmitted again. But that's really the thing. If we can track that individual unit whatever that is, I think it's relatively within reach. So cotton gins are actually a continuous flow process. So once you get what's called the roll, which is moving on the gin stand that kind of keeps the seed getting separated from the clean fiber, you don't really want to stop that unless you have to. So by nature, the cotton gin itself and the ginning process is a continuous flow process. So that means there's always a little bit of guesswork, and kind of creating some ideal situations where you're tying this exact input module to this exact bale that comes out. But this is how I've been thinking about that. So each one of those modules generally create about 4 bales of finished cotton, right? So the big round module that's identified with an RFID tag, and when it goes in, it gets ginned and it creates about 4 bales. So if we think about that module coming from 2 to 3 acres typically in picker cotton, then even if we're off a little bit on the bale, we're really only going to be off somewhere around 1/2 to 3/4 of an acre, right? And so I think that resolution is definitely actionable. So I think that even if we're dealing with a continuous flow process, I still believe that it has a lot of value. And we were able to create or to identify significant differences in those fiber qualities, even through this imperfect process. There's a lot of farmers who treat their day-to-day operation, their field practices, as a sort of intellectual property, right? It's their secret sauce. It's how they make their crop. And I think there is some hesitation around opening that door. The fact is that data ownership has yet to be fully defined in the court system. So there's really no precedence. Nobody has created the historical record that says this is what ag data ownership is. It's very much still up in the air. But absolutely, there can be situations where, let's say in that harvest ID file, that it shows that cotton module was harvested pretty wet. Now, when it gets to the gin, they may have to incur some additional cost to dry it and get it where it's at. So now you start seeing this idea of, would that cost remain still at the gin, or does that get transferred? So you're absolutely right. There are places where we're only thinking about the value of that data in terms of creating more value, but there are definitely places where it could get used in a way we weren't thinking about. And that's what I did mention before about the idea that now that there is an audit trail, once the audit trail is there, somebody will audit it. So there's not going to be any room for juking the stats, or for, twisting the numbers. So you're going to have to be transparent when that time comes, I think is the key thing. Yeah. But the data ownership is actually, it's really about your own comfort level with it. Right now in that current system, the only data that would be leaving the farm in the cotton system is that HID file, right? That connects the module to the field. That currently is the only file that would be moving with the system. So all the other analyses that would happen about inputs or field management practices, those are still staying within the farm. Okay. So I think there's this idea of this little piece of information has to move, but you don't have to let all of your information go with it. And I think that's made it more accessible. And that might be a good model to think about as we move forward with this and other crops. Yeah. The fact is, we've been talking about identity preservation of crops for a long time. When I was in graduate school in the early 2000s, this was an idea that we were kicking around. But I think what's really happened now is the connectivity, the data availability, the technology, and not just the hardware, but the ability to think and to manage and to handle all these pieces. We're really just now to the place where we can start delivering on that identity preserved crop promise that's been around for a while. I want to definitely acknowledge the role that Coastal Carolina Gin and Todd Waters and our collaborators, all across Eastern North Carolina, for allowing us to come in and observe their work and allow us maybe to create a little bit of additional labor here or there for them, because that's what allows us to get to this information that we think has so much value in the future. So we really want to appreciate them. And of course, I want to continue to thank Cotton Incorporated and Ed Barnes for their support, or else we wouldn't have been able to fund this work. So I really appreciate all those individual stakeholders and the combined effort that they've been able to give.